Hello everyone, let's solve a very good set on data interpretation in which we'll be using ratios, we'll be using graphs, we'll be using tables, and we'll also be using the concept of percentages and time and work as well. So let us start reading the set. The question is, ABC Infratech was given a contract to work on drainage system of mall at New Delhi. The project was divided into 4 different parts, 1, 2, 3 and 4. Each part was worked upon separately by a team of workers. There were 3 different kind of workers in each team: plumber, assistant and supervisor. The number of days the workers were employed on each part is 22, 21, 20 and 18 days for part 1, 2, 3, 4 respectively. The following table gives the percentage wise distribution of the workforce working on each part. So there is some work to be done and it has to be done in 4 different parts, 1, 2, 3, 4, and those parts have been given to us in the bar graphs as well. Then this work will be done by 3 different type of people, 3 different type of workers: plumbers, assistant and supervisors. Now after that we have been given that on part 1 workers were employed for 22 days, on part 2 workers were employed for 21 days, on part 3 workers were employed for 20 days and on part 4 workers were employed for 18 days. Then this graph that we have, it is showing us that on part 1 there were 30% plumbers who were working, there were 50% assistants that were working and the rest 20% were supervisors that were working. After that, it is known that particular worker supervisor was not absent for more than 20% of the work days. So all these workers supervisors, they are not absent for more than 20% of the work days. Maximum percentage of the days that they can be absent for is 20%. Then the following table shows the man work days employed in the project. So on part 1, plumbers have total 328 man days, assistants are working for total 553 man days and supervisors are working for 215 man days. Similarly we have it for part 2, 3, 4 as well. Let us read the questions that we have. First one is, how many supervisors were allotted for part 1 of the project? So using all these clues we have to find out how many supervisors were working on part 1 of the project. And second question is, how many plumbers were employed in the project? So we have to find out the total number of plumbers that are employed on the project. We'll find it out only after we find out the number of plumbers in each and every part. So we'll go to the next slide. We'll start solving the first question. So in the first question, how many supervisors were allotted for part 1 of the project? So we basically have to focus totally upon supervisors. And we are talking about part 1 of the project. So we'll be picking up data only from part 1. Now in part 1, the total work by supervisors is 215 man days. And we were also given that it is known that a particular worker or supervisor was not absent for more than 20% of the work days. So here what we can do is, either we can take 0% absenteeism and we can take maximum 20% absenteeism. If we talk about 0% absenteeism, that means on part 1 we know that work was being done for total 22 days. So if there is 0% absenteeism, that means on part 1 all the supervisors, they'll be doing the work for all the days. So they'll be working for total 22 days to complete these 215 man days. So this 215 units work has to be done in 22 days. How many supervisors will be needed? So when we calculate the number of supervisors needed when there is 0% absenteeism, it will be 9.7, approx 9.7. But we know that number of supervisors can never be in decimals. It has to be an integer. So minimum 10 supervisors must be there to finish this in 22 days. So minimum number of supervisors must be 10. Now when we take the case of 20% absenteeism, in that case also the total work is 215 man days. So if we assume that 100 man days is the total work that is supposed to be done, in that case due to 20% absenteeism, only 80 man days will be the work that will be completed. And this 215 man days that we have over here, this is also the work after 20% absenteeism. So we'll write it down just after 80 over here, because it will also be equivalent to the work due to 20% absenteeism. So 215 man days will be the work due to 20% absenteeism. So what should be the actual work in that case? So we'll use the method of cross multiplication over here. Actual work that must be done, it should be equal to 215 into 100 by 80, which gives me, then we get it as 268.75 man days. This must be the actual work done. Now if this is the actual man days or the work that we are getting, what should be the number of supervisors to do this amount of work? It must be 268.75. the work is being done for 22 days on part 1, so we'll have approx 12.2 supervisors. Now since this cannot be the number of supervisors because it is in decimal, so we'll take the number of supervisors to the closest integer, it will be 12. So the maximum number of supervisors can be 12. So now we can have the number of supervisors from 10 to 12, because 10 is at 0% absenteeism and 12 is at 20% absenteeism. This is the range of number of supervisors that we have. Now in the exactly similar manner, we'll try to work upon the number of assistants. So I'll erase all this. So if we look into the case of assistant over here, the total work is 553 man days. In case of 0% absenteeism, the number of assistants will be 553 by 22 days, because on part 1 the work is being done for 22 days. So this will be equal to 25.13. So the minimum number of assistants that we'll have, it will be 26. Why? Because if I take 25 as the number of assistants over here, then 25 assistants, they will work for 22 days, which will give me 550, but our work that is to be done, it is 553. So this will be less than 553, hence we won't be taking the number of assistants as 25, it will be 26. This will be the minimum number of assistants. Now we'll try to work upon the case of 20% absenteeism. So this is over here. When we have 20% absenteeism, we'll again do it like we did for supervisors. 100 man days will be the work. Due to 20% absenteeism, it will be 80 man days. So now the work that we have been given in the table for assistant, it is 553 man days. It is due to 20% absenteeism, so we'll write it with 80 man days. After cross multiplying, we'll be getting the value of actual work days as 553 into 100 by 80, which gives me, so the actual work will be 691.25 man days. This will help me to give the maximum number of assistants. So how will we find out the maximum number of assistants? 691.25 will be divided by 22, which gives me, it gives me 31.4 as the number of assistants. So we'll take it as the nearest integer, which will be 31. So now we also have the range of number of assistants. Minimum is 26, max is 31. Now in the exactly same manner, you can do it for plumbers as well in part 1. Now what we will do is, using these ranges that we have of number of supervisors and assistants, let us use this graph that we have for plumbers, assistants and supervisors. If you find out the range for plumbers, it will be 15 to 18. Now let us read this graph. So in this graph, we were given the percentage wise distribution of the workforce, that means the number of people that are working on it. So for part 1, if we read it, this is 30, this is 50, this is 20. So what will be the ratio over here? The ratio of blue is plumbers, then red is assistant, then green is supervisors. The ratio is 5:3:2. So now we have number of plumbers, assistant, supervisors in ratio 5:3:2. We also know the range for each. For plumbers, the range is 15 to 18, that means 15, 16, 17, 18. These can be the number of plumbers. Then for assistants, the range is 26 to 31, so 26, 27, 28, 29, 30, 31. These can be the number of plumbers. For supervisors, the range is 10 to 12. So 10, 11, 12 can be the number of supervisors. So now we have to select one number from each bracket so that we get the number of plumbers, assistant, supervisor in ratio 3:5:2. So if we pick up 18 from the first bracket, then if I pick up 30 from the second bracket and 12 from the third bracket, then we can say that the number of plumber, assistant, supervisors, it is in ratio 3:5:2. There are no other values that will give us the same ratio 3:5:2. So we can say that this is the number of plumber, assistant, supervisors that are working on part 1. So in the similar manner, you can do it for part 2 as well, part 3 as well, part 4 as well, and you can find out the number of plumber, assistant, supervisors that are working on each and every part. So let me directly put down a table over here in which I'll be writing down the number of plumbers, assistant, supervisor in all the parts. So we'll have part 1, part 2, part 3, part 4. We'll be having plumbers, assistant and supervisors. So in part we got plumbers 18, 30 assistant, 12 supervisors. In part 2 we'll be getting 30 plumbers. In part 3 we'll be getting 42 plumbers. In part 4 we'll be getting 16, 30 over here, 15 here, 60 here, 18 here, 32 and 16 here. This will be the final table that we'll have, and it will determine the number of plumbers, assistant, supervisor in each and every part. So using this we can easily solve all the questions. Let's try to solve the first one. So the first question is, how many supervisors were allotted for part 1 of the project? So very clearly we have 12 supervisors. Option A will be the correct answer. Let's try to solve the next question now. Second one is, how many plumbers were employed in the project? So how many plumbers? That means we have to find out the total number of plumbers. 18 plus 30, 48 plus 42 is 90. 90 plus 16, 106. Option A will be the correct answer. Let's try to solve the third one now. The third question is, how many assistants were employed in project 3 and 4 combined? So we'll go back to the previous table in which we have all the data. We have to find out assistants in project 3 and 4. So assistant in project 3 is 60, in project 4 it is 32. If we add them we get 92. Option A will be the correct answer to this third question. Fourth one is, had there been no absentees by supervisors and plumbers in part 2, then what would have been the man work days for part 2? So now we are talking about part 2, and we have been told that there are no absentees in case of supervisors and plumbers. So in part 2 work was being done for 21 days. So that means for all 21 days all the supervisors will be working. So in part 2 there are 15 supervisors. Then in part 2 there's no absenteeism in case of plumbers, so all plumbers will be working. In part 2 we had 30 plumbers, so all 30 plumbers will be working for 21 days. And now we need to find out the total man work days for part 2, and we have to find it for assistants. So it was directly given to us in the table provided. In part 2, assistants, these were working for total 522 man work days, so we'll add 522 to this. So when we calculate this we get 1467 as the total man work days for part 2. Option A will be the correct answer. So this was a very calculative set, but I hope the explanation was clear to you. If there's a doubt, please ask again. Thank you.